All right, let's create our first multi-index data frame. I'll begin by re-executing our standard code to bring in our Big Mac dataset. And as a quick refresher, in a few modules ago, we discussed the setIndex method. It's called directly on a data frame. And in our previous examples, we gave it a single argument, which was usually the name of a column. And what it did was take that column or that series and set it as the new index of our data frame. So for example, if I passed date here, we can see that the date column was moved from being a regular column to serving as our index here on the left. We can tell that it's the index immediately because it's bolded and kind of highlighted. And if I click back into my parentheses and use Shift-Tab to look at my documentation, we can see that that date argument is going to a parameter called keys. So this is what we've been giving our column names to. And as another example, if I wanted to instead set it to be the country column, that sets the country column as our index and moves that column out of our data frame. Again, until we used the in-place parameter, it doesn't actually modify our original data frame. So in all previous examples, we passed single strings representing the column name that we wanted to set as our index. And as I introduced in the previous lesson, a multi-index is just an index with multiple levels or multiple layers. And what that means for us is if two levels are used, it just means that two values will need to be passed to determine what row to extract. We're basically just adding an additional dimension to the index. So let's take a look. And how can we possibly specify that we want two different values to be passed as the index? Well, by now we should know that the ideal data type to represent more than one value is a Python list. So instead of passing a single string here, I'm going to pass a list. And the two columns here that I want to use as my index are going to be date, which is my first column, and then country. So let's see what happens. So now we can see that we've created a multi-index data frame. On the left, we have our date column. It's our most outer layer. It's our first kind of parent level, and that's because we passed it first. And we can see here that it actually doesn't appear, the value doesn't appear until a little bit further down. And the reason for that is because this first date, which represents January 2016, is the same date value for all of these countries that we have right here. So in our original data frame, if we take a look at our data up here, we can see that the same date exists for all of these countries. So in a way, Pandas realizes that we have an identical grouping, and it performs a somewhat of a pivot operation, but not really. It just moves it all to the index, but it realizes that because the date here is exactly the same, there's no need to repeat it for every single row. We have these countries, and they're all kind of nested underneath that common outer date, which is the 1st of January 2016. And here we have our little bit of truncation, and then we end with the oldest date, which is January 1st, 2010, and all of the countries are represented within that date as well. And if I just reverse the order here, what we can see is we can alter the way that the multi-index is structured. So if I want country as my first column, or my first level of the index, and then I want my date, I can just reverse the order of that. And you can see that now country will show up here, and within each country we'll have the date as the second level, the second layer of my multi-index data frame. Now let's bring it back to my original view. I like that one much better. I think the general best practice in data is that the column that has the least number of unique values should serve as the most outer layer, and then as you move in to each next layer, you should follow that pattern where each further nested layer has less than any upcoming layers. So for example, if I had a 3 or 4 column multi-index, in that case the most outer layer should have less values than the next layer, which should have less values than the next layer, which should have less unique values than the final layer, and so on. So we have less unique dates here than we have unique countries, so it's probably best to put the date as the outer layer of my multi-index than my country. But here we have it. And let's say I want to make this permanent. I'm going to use the familiar in-place parameter here. And I'm just going to preview the first, not boys, Big Mac, the first 3 rows of my Big Mac data frame. And there you can see we have our outer layer, which is the date, and our inner layer, which is the country. We can see that the column names that we've passed in here are going to be represented up here, so they don't disappear. And now let's say I just want to call the sort index method to see what's going to happen. And what's actually going to happen is it's going to sort both of the indexes piece by piece. So as I scroll down, you'll see that we've replaced it with the date, the earliest date, which is January 1st, 2010, because the sort index method is actually going to sort each one, and the default is ascending. So it's going to sort the dates in ascending order, which is the outer layer, and then within those dates, it's going to sort the countries in ascending order, which means alphabetical. So let's say I want to keep this operation, so I'm going to make this in place equals true as well. And now if I preview my data frame, I have a nice sorted professional multi-index. Let's just dive into a few familiar attributes and functions that we can take a look at here. We have our index attribute. Now, when we previously called our index attribute, we usually would get a single object back. Now we have a multi-dimensional index. So when I execute this, you'll see that we'll actually get a brand new object. It's called multi-index. And you'll see that within it, it's going to represent each of the layers. You can see that the first thing it says is levels, which represents all of my dates. And that's going to be stored as its own internal array. And then finally, we have a comma, and then another array that's going to represent the internal countries that are stored within that second level or that second layer of my index. If I call the names attribute on this attribute, kind of funky, but it works, we'll get the list of labeled names that make up my 2 layers. So we have date on the outside and country inside. And by the way, if I take my index attribute, which returns my multi-index object that represents my index in my data frame, if I pass this to Python's built-in type function, we can see that it is a separate object in pandas, much like the data frame is an object, much like the series is an object. Whenever we use a multi-layered index, it sticks to another brand new object called multi-index. So behind the scenes, the puzzle piece that's now making up our data frame right here is a different object. It's a multi-index object instead of the default one. And finally, let's just do one other thing. Let's extract from this index attribute. You can see that it's a list. So if I enter 0, it's going to return the very first item in my list, which represents my very first row value. And you can see that it's giving me a tuple that represents a combination grouping of a value from my outer layer and my inner layer. So the very first thing here is the date of January 1st, 2010, and a country of Argentina. So the very first element in my index of all of the labels is not just a single value like we had in all previous data frames, but a combined tuple that combines both a timestamp, that's the outer layer, the most upper level, so to speak, and then a second component, which is the inner layer, which is my country. So this is going to become particularly helpful when we start talking about extraction. Previously, when we've extracted values from a data frame, we've had to provide a single value for the row, so Pandas knows what index position or what index label to extract. Now, because our index consists of multi-dimensions, we're going to have to pass a tuple in order to indicate that we want to extract more than one thing. We need to indicate what combination of date and country form the label for the row that we want to remove from our data frame. Then we'll dive into all of that in a much later lesson. But really the key takeaway here is that every row now within our data frame has an index that is 2 parts. It has a date and it has a country. This is just a sample that we're looking at here, the very first row. But every single value has that identical structure and now has 2 values that make up the index or the label that identifies that row.